Can you give us an overview of how AI and machine learning can help us to approach risk management in a more effective way? If you could give us a high-level overview as to where is the value, uh, how much does it take for a company to embrace this type of technology?
I mean, it's actually very interesting, right? I mean, we talked about effective implementation and integration of risk management just now, right? You know, but the whole question is, how do we do that? Where I mean, in our view, in the ways that traditionally it has been done, is about establishing a risk management framework. You're trying to embed that risk management into the process. Once it's in the process, people are trained and communicated on how this is going to work as part of your process. That then gives you continuous opportunity to monitor and improve, which then helps in kind of become a cycle where you're re-engaging with the framework and all that, right? Now, as you kind of break this down, framework is more of a strategy element of it,
Right.
but identifying the pieces in the process where you need a lot of data and data-driven information that can help you effectively manage those risks. There are ways and means where it has happened in the past. I mean, traditionally, how did we do it? And when we talk about risk, right, this starts with anything from basic elements like transactional accuracy to internal controls to processing errors to frauds to cybersecurity. I mean, a whole gamut of things are within that component. And how do you monitor that? Traditionally, we used to do sample-based testing. Then we progressed into a bit of analytics with tools and Excel macros and some off-the-shelf products. Later, we migrated into doing a little more deep analytics and writing specific codes to do that. Today, that's become a far more superior capability where you're using enhanced techniques like machine learning and algorithm that identify patterns that uses data analytics to a very powerful extent. You can detect anomalies, you can predict risks, you can have fraud detection tools, etc. All this is built in and using the power of machine learning algorithms. I was just to give you an example, I was talking to a large global business service provider the other day, and they were talking about using transactional data of service parts and engineering components and maintenance information to predict when a part in an aircraft would fail or when a part in a railway system would fail. I mean, 10, years and decades back, that was not possible. Today, we are talking about advent in technology using AI and machine learning and algorithms, etc., to be able to do that. I mean, we do similar things in our customers, right? We are able to identify human errors. We are able to identify, payment mistakes. We are able to detect and stop erroneous payments, phishing, etc. Journal entries, accounting mistakes, contract errors. So there are so many different areas where your business is getting affected, and the application of technology on that relevant set of data and using the right technology also makes the difference. It's not about just having AI and machine learning, right? I mean, today you're talking about advent of things like generative AI components, especially in using chat GPTs and others, right? I mean, yes, what can they do today? They can research large data sets and extract key information. You want to look at, gap guidance to look at how have you treated a certain transaction. Can generative AI use US GAAP principles and look at the transaction, give you a contextual response? Yes, it can do that. It can translate, interpret data from your financials and give you a story that you can talk to your investors. So there are so many of these things that was there. But again, it's all about identifying the key process that you're trying to monitor and manage and the most effective technology to apply on that. Yes, AI, machine learning, etc., gives you more superior power and ability to understand various dimensions and vectors of that data set in a very focused manner. So let me give you a small example here. We have always spoken about, every business we understand duplicate payments, vendor duplicate payments, right?
Yes.
Traditionally, every system offers vendor duplicate payment analysis. Why using machine learning and specified pre-trained algorithms are softwares like ThinkRisk being able to produce accuracy that is 1,000 times better than any other systems that's produced? It's because the different vectors, right? You have multiple, your combinations of analyzing a transaction is not just vendor name and amount and invoice and so many things. There are 65 to 64 to 128 different vectors that are involved in looking at various data points to be able to identify that, which then translates into an outcome that is more precise and that is more focused on what you want to manage
Mm.
rather than traditional systems producing. Yeah, I used to work on a lot of ERP systems, and we used to get duplicate invoice reports. It used to have hundreds of them, and then you go through that at the end of the month. When you actually evaluate that, you probably might find one or two of the hundreds that you got on the list. So there's that's the element of balancing the accuracy, false positives, the risk appetite, and all that comes into play. But ultimately, now you're trying to get the information that you really need to manage your business better. And that's what the power of AI and the other solutions are bringing to the market now.
Jagdish, help me to understand one term. You use the term vectors as a differentiating factor. Can you explain to the audience what do you mean
Yeah,
by
so
vectors in a non-technical way, please?
correct. When you actually think about it, right, if you kind of draw a graph, I'm sure everybody would have seen some murder investigation on Netflix or something, right? I mean, you find people putting a picture and then connecting to another picture, and I mean, Homeland. I mean, Carrie was just super at that, right? Every wall she had, there was pictures and ropes tied to it. It's a very similar approach to you take an invoice data and connect it to all possible information around that, whether it's a vendor data or account, the payment information of the vendor for the last 5 years, and what kind of material we have produced from this vendor, and what were the average prices in the market. What price are we paying? Did we pay this before? Did we not pay this before? Why did we not pay this before? There's so many different data points, and we call all of them as different vectors from a perspective of analyzing. So I
Oh, okay.
so when you kind of when you kind of think about it, it's that big connected picture chart with ropes on a detective scene.
Mhm. Okay,
It's
so
it's very similar.
can I say then that a vector is like a data attribute?
Yes,
Okay,
absolutely.
and the value of AI and ML would be that you would be able to look at more data attributes to, let's say, determine if there are duplicate payments in the
Correct.
AP area.
Correct. I mean, it's not a set number because you have written a code. So when you write a code or a macro or something, it is defined that what it's going to do. Whereas when you use an algorithm, the algorithm generates patterns, it generates analysis, looks at things that has happened in the past, tries to connect all kinds of information that is related to that particular transaction to come up with the potential outcome for what that is.
Okay.
So you can actually scan through millions of data points to come to a conclusion on whether a particular data that is provided is correct or not.
Okay. And my next question is, when the system tell us that there is an anomaly, does it system tell why is a problem, or it just shows that there is a problem and that's it?
Yes. So this is something that ThinkRisk actually, as a product, we were really focused on, right? We wanted to give the user a journey using the outcomes as much more augmented to his reality. What do I mean by that? We wanted to have the ability to take the data that is available in your ecosystem, produce outcomes that are meaningful to you, and explain those outcomes to you, right? So if you look at a product and it says it's an Excel sheet with a bunch of transactions in it, which are exceptions, as we used to call in the risk management space or internal audit space. Okay, I've got a bunch of exceptions. Now I have to go follow up on each of these exceptions. One, to understand why they're exceptions. Two, is there material? Three, do I need to follow up? Four, if management has done something, what has happened? Now, the amount of time that it takes to do all that is kind of laborious, not knowing what you're heading towards. So with solutions like ours, we kind of flip that around, saying that, okay, I'm going to give you an exception. The exception is going to be a high probability of truly being an anomaly. And these are the reasons why we have classified this as an anomaly. And here is the category of anomaly that it falls in.
Mm.
So which then gives you as an end user the idea, the visually um, uh, the visual appeal in terms of seeing, okay, I can see a problem, I can see what caused the problem, I know what needs to be done to fix it. Let's go ahead and do it. So the intelligence has kind of come to that full strength where you're able to now gather data, analyze the data, produce an outcome, explain the outcome, and drive an action out of it.
Okay, perfect. I think it's very valuable that the system can pinpoint what is the reason of the anomaly. I think that's
Yes,
a
I
lot of
mean
value
the
for
ability, correct. And the whole objective is to make the life easier, right? We are empowering users to do what they do best, which is use their intelligence and use their intelligence and are able to make decisions correctly rather than spend time in identifying and detecting problems and scanning through a haystack to find the needle.
Okay, okay, good, good.